Hi everyone. I just recorded this video and now I have to redo it because I deleted it somehow. So this is my second shot. We're going to talk about special right triangles. So they have angles 45, 45, 90 and 30, 60, 90. And knowing those angles, you can find the sides without even doing the Pythagorean theorem. So that's kind of nice. So here are the theorems. I'd like you to pause the video and write them down. So the 45, 45, 90 triangle is pretty easy to memorize. The two legs we have here, you're just going to find the hypotenuse. All you have to do is take the legs times the square root of 2. That's all you got to do. Now the 30, 60, 90 triangle gets a little tricky. So across from 60 is going to be s square root of 3. Across from 30 is always going to be s. And across from 90 is always going to be, I'll make a different color here, 2s. And so you have to have that memorized, or you have to know that. And we're going to talk about in class why that is. Why is the 2s across from 90? Why is the s square root of 3 across from 60? And why is s across from 30? All right, so you might have a better understanding with that. So think about that before class. So let's try some with the 45, 45, 90 triangle. So we have 4 as a leg, and keep in mind this is 45 as well. If you know that one angle is 45 and one is 90, you know the other one's 45. So x is going to be 4 square root of 2. That's all you gotta do is attach the square root of 2. So let's go down to this one down here. We have two legs that are 5, so we know that these are going to be 45 when we know the two legs are the same. So it's going to be 5 square root of 2. Now this one's a little different. We have a leg that's 7 square root of 2, but don't let that fool you. X is still going to be, or the hypotenuse is still going to be that leg times square root of 2. Now can we simplify this? Since we have the square root of 2 times the square root of 2, we can put them together because they're both radicals, which becomes the square root of 4. So what is the square root of 4? It's 2. So 7 times 2 is going to be 14. So x equals 14 for that one. So that's a little different, but you still use the same rule. Okay, that's the easy part. Now let's try the 30, 60, 90. Okay, so across from the 90 is going to be 2s, and I always like to label it just so it helps you memorize it. Across from the 60 is s square root of 3, and across, this is going to be 30, across from 30 is going to be s. So since we know that 10 is the 2s, we can go ahead and figure out what s is. S is going to be 5. So x is going to end up being 5. And I know that's difficult to see there. The 5 and the s's is kind of confusing. Not very good example. If you want to use another letter besides s, feel free to do so. So if x equals 5, or excuse me, if s equals 5, then y is going to equal 5 square roots of 3. So again, it comes down to knowing the 2s, s square roots of 3, and s. Where are they placed on that 30, 60, 90 triangle? All right, let's try another one. Okay, now we have 15, which is across from the 60. So 15 is across from 60. Always across from the 60 is the s square roots of 3. This is 30, so this is going to be your s. And across from the 90 is going to be your 2s. So since I know 15 is equal to s square root of 3, let's go ahead and find what s is going to be. Well, I divide by the square root of 3 on both sides. So now I have s is equal to 15 square roots of 3. Now in math class, it's a big no-no to have the square root on the denominator. So how can we get rid of that? Well, if you looked at the previous examples, a couple examples ago, a square root times a square root gets rid of it. Gets rid of that radical sign. So let's go ahead and times by the square root of 3. Now if I want to times by the bottom, guess what? Got to times by the top. We don't leave anybody out in math class. So on the top we have 15 square roots of 3. And the square root of 3 times the square root of 3 is the square root of 9. Well, what is the square root of 9? It's 3. Okay, so I have the square root out of the denominator, which was my goal for doing this. Now, 15 over 3, can that be simplified? You bet. It's 5 square roots of 3. So s is going to be 5 square roots of 3. So that's what x is going to be. Now y, since it's across from 90, is going to be 2s. So we have 2. Y equals 2s. So y equals 2 times 5 square roots of 3. So y is going to be, we can go ahead and put our whole numbers together, 10 square roots of 3. Amazing. And again, rewatch this if you need to. Rewind and rewatch. You might have to watch it a couple times, but trust me, you'll know this for the rest of your life. A lot of people do. Okay, let's try another one. Very, very similar. Across from the 60, remember that's s, square roots of 3. Across from the 30 is s, and across from the 90 is 2s. So let's go ahead and set this up. So we know 12 is equal to s square roots of 3. Go ahead and see if you can find out what s is. See if you can do it on your own. Go ahead and pause the video and try it. Okay, so the square root of 3, we're going to divide by it. So now we have s equals 12 over the square root of 3. Got to get rid of that. So now it looks like we have 12 square root of 3 over 3, because remember this is the square root of 9. 12 over 3, that simplifies down. So we have 4 square roots of 3. So s is going to be, which is x in this case, 4 square roots of 3, because s and x are equal to each other. Now we got to find y. So remember y is equal to 2s. So it's equal to 2 times 4 square roots of 3. We can go ahead and put 2 and the 4 together. It's going to be 8 square roots of 3. So y equals 8 square roots of 3. Perfect. Again, rewatch that part if you need to. We only need to times the denominator by a square root only if you're dividing by a square root. Okay, if you have that in there. If you want to get rid of it. Okay, so I'm going to give you the practice problem so you can work ahead if you want to. Come with questions to class, and I hope you guys have a wonderful day, evening, morning, whenever you are watching this. And yeah, spring break's almost here. Woohoo! See you later.